Welcome, my friends, and thanks for joining me. I'm Lorna Schumann with the Illinois State Museum, and today we are once again in the Changes exhibit at the Main Museum in Springfield. And this exhibit looks at 500 million years worth of changes in Illinois history. So that's something to kind of think about that's really interesting and cool. And when we start looking at it, what we're going to focus on today is how what's below us in the earth affects the surface upon which we find ourselves, like these layers that are behind me. So in order to really discuss and talk about how what happens below us affects us, we have to understand what the earth is made up of. So think about that for a moment. What are the layers of the earth? So one of the ways to think about it is we have an egg, a hard-boiled egg, or you can make it semi-hard-boiled. But the egg really has 3 different pieces to it, or layers to it, just like the earth does. If I was to crack this open, we would find in the very center of it the core, which is the yolk. And that would represent like our earth core, which has both the inner and outer core. And then the white of the egg would represent the mantle, which is kind of fluid and semi-solid, kind of like silly putty, so it still moves. And it's extremely hot, with the core be even hotter. So as you move outward from the core, it gets cooler. But the mantle is where a lot of action takes place because of the heat and the change in temperature between the core and the outer layer, which is the shell here, called the crust. So think about that for a moment. If we were to cut our earth open, it would look like this. You can see our core, you can see the mantle, and you can see the crust. Well, great job. Because when we talk about this egg representing our earth, it can help us understand how pieces happen. So think about this way first, is that we have our mantle. It's semi-fluid, hard, solid, but it's moving. And the piece near the core is super hot. And up near the crust is much cooler. So what happens is you begin to get convection currents. Think about it as a pot of hot water boiling on the stove. And that near the stove top is really hot, and the water up near the top is cold, and so you see bubbles. That's really like convection currents. So how do convection currents work? So what happens is they boil. And what happens is heat rises. That's just how it works. So as the heat rises to the surface, it runs up against other pieces rising to the surface. And it starts to create these currents that move like this. Well, once they hit the surface, they cool off. And cool sinks. So then what happens is the coolness sinks back down towards the core in the mantle, and then it gets heated again and it comes back up. So pretty soon you have these currents going like this. So a good example to show you is that we have these circles happening. So here we have 2 connecting, they rub up against each other, they split when they hit the shell. So let's go back to our egg. Remember our egg? Well, all this pressure on here also tells us something else. I'm sure some of you have heard of plate tectonics. Well, how does that work if we're using our egg metaphor? So let me show you. I'm going to create some plates on my egg. You ready? So here we have our egg, and I'm going to crunch my egg, creating on it pieces and chunks that are like the plates on the earth. So then you can see these different pieces that are plates. Now remember the mantle below? It has the convection currents that are starting to make it move. So how does that work? Let's think about it for a second. So let's look back at this picture right here. This shows our convection currents coming up. They hit the plates, and as they separate, the plates move with the convection current. Now this happens very slowly and does take a long time. But what you have is the places where the current is coming up and it splits apart, you have plates pushing apart. Where they come down together like this is where you have the plates crunching together, one usually going under, one usually going above, and it melts part of the crust into the mantle. So it drags part of the crust into the mantle and creates a recycling for the planet of its rocks. So when we think about that, we have about 13 different plates on the Earth. This is a picture of all the plates that they think we have. And I'm sure some of you have heard of the Ring of Fire over here, which is where plates are being pushed together, which is causing volcanoes and earthquakes. And then you have over here in the mid-Atlantic where plates are being spread apart. And what's happening there is that you have the plates opening up, and as they open up, pieces from the mantle, the magma, comes up to the surface, cools, and rebuilds crust. So on different pieces of the Earth, you have crust being pushed under and built up to create mountains, and then that crust that's pushed under the surface is melted, where on another place on the Earth is you have the Earth pulling apart and creating new crust. It's really a cool idea when you start thinking about it, that our Earth has all this action to rebuild and recycle our rocks, not just the rock cycle that we have. But it also helps us explain how our Earth has changed over millions of years, and how for us in Illinois, that Illinois was once south of what we call the equator today and is now north where we are. It's all based on the plate tectonic movement. Well, I have one more thing to show you. Are you guys ready to go see it? All right, let's go look. So my friends, here we are to see kind of how the changes in the geology have happened for us. So think about it here in Illinois. When we look back at our layers, which is part of our crust, it can tell us many different things. So if we look down here, we first see tropical Illinois, which is really cool. This is the oldest piece that we're able to see here in Illinois. As we go up through this area, we start getting this question mark, which is all gone, and that has to do with the glaciers. And then we move to frozen Illinois, which is the Ice Age period. And then all the way up to the top where we are now is the current interglacial period. So these rocks help us understand a little bit about what we have on our surface that is affected by what we have below. Well, my friends, I hope you learned a little bit more about geology today and how what's under our feet can affect us here on the surface. Thanks for joining me.